Okay, welcome everyone at this presentation about Cloud IAM and IAM and RBAC. It's a presentation meant for everyone, including product owners and project leaders and developers. This is a presentation at Q42, but it's gonna be shared with everyone. If you have any questions, please put them in the comment section, and I will also sometimes enable this button, which allows you to go to a certain link and pose a question or provide some input. So please go to that link then and fill it in, but it will hide it now, I think. Okay, so let's start. Why this presentation? So security is part of our job as a developer, and it might sound boring, cloud rights and access management, but it's not boring if done wrong. So the GDPR and states what you must do, and if you have a data leak, the fines will be not so pretty, and that's the thing you want to avoid. So with this presentation, I hope to bring you a bit up to date with the terminology and the technology. And if any of the developers mention some terms, then the product owners at least know what they're talking about if you have watched this terminology section. The key takeaway will be that you should always give your application as minimal access as it needs. So don't over-grant permissions. And the references at the end will contain some useful links. You can always go back to this presentation and view those when you need to do something with Cloud IAM. So why is this relevant? So if you have an application in the cloud, it doesn't matter which provider. You have, for example, these two applications. They're running on VMs. The app web is one application. The app admin is another application. And they are running Node.js, for example, and this left app has a npm module, which is called Leaky, and which is, yeah, the name is what it does. It does what it says in the name. The applications use some cloud services, so they use the event queue, managed database, and network API. This in Google Cloud, this is called PubSub, Data Store, and a network API. But in all the other providers like AWS and Azure, those services also exist and have different names. As you can see, a hacker will now infiltrate this app because the npm module is leaky and is used in Express.js. So somehow it gets in this application, and consequently he gets access to all the services that this application uses because he has full access to the what's on disk, and he has access to the credentials of this application. So that's a thing we want to avoid. So what you can do is you can have fine-grained permissions. So instead of specifying your whole project to use the same credentials, you can specify credentials per application. And you can ensure that the web app can only access the event queue, and the other application can access other things. In this case, all of the things, but the way it accesses the event queue is different. So it will only read and not write. So if an attacker then gains access to this application, he only has access to the event queue, and the attack service is limited very much. Suppose that this database contains salted passwords. Attacker would have stolen it in the first scenario, but in the second scenario, he can't even access it. And even worse, in the first scenario, he could access the network API. So he could create a front-facing website to steal users' passwords while they are entered in the web UI. And then he wouldn't even need the salt, or he would circumvent the salt. So you want to really avoid these kinds of privilege escalation. So that was the introduction. Next up, I will talk a bit about the terminology of IAM and RBAC. I have a challenge, and then we'll deep dive a little bit in compute. That's the same thing for AWS, Azure, and GCP. It's about running VMs on the cloud. And lastly, about Kubernetes, which is a way to run Docker containers in a more granular fashion than using VMs. And that also brings its own possibilities for fine-grained access. So your application code uses, for example, a database, logs, and monitoring, which are managed services by the cloud provider. So in GCP, this is Stackdriver for logging and monitoring, and the data store. But that's the same for every provider. And you can specify credentials to those services using plain credentials like a user password, but also a connection string is often used, or some other way of automatic provisioning. So your code, what is it? It is an application which has an identity. So you could call it, for example, My Awesome Website, or you can call it Rijksweb or Rijkscms, or you call it something weird like Freddie Mercury, and that's your identity. Then you have a role. So this your code acts as a web server, for example, and you can create a role which is my web server role. A role is a collection of permissions. So in this this terminology, it is at least. So you can, for example, the role my web server role has logging permission, data store read permission, and pub/sub subscribe permissions. Actually, a role binding or an IAM policy describes such mapping between identity and a role, and between a role and a permission. Is this clear to everybody? Are there? I'm not sure if everybody knew this already, but this is the basic, and I will continue. You can even have multiple roles, of course. So you can have different applications which have this different set of permissions. Well, then IAM and RBAC, Identity Access Management and Role-Based Access Control, they are quite similar, actually. These pictures are from a terminology page by Hausenblas, and you can see that, well, the images are different, the same concepts apply, and the most important difference is that in IAM you have a policy, and in RBAC you have a role binding. If you see an implementation of this concepts, you see that here in the VM is shown in red, so EKS CTL Fluent Bit is VM in AWS. It has an inline policy to the Fluent Bit DS policy, which has the permission, defines the permission put record batch to the firehose, which is a service. And in RBAC, in Kubernetes, for example, you can have a pod Fluent Bit, which is a container, and it has a role binding, which binds it to the pod log reader role, which has the rules, the permissions to access namespaces and pods with the get, list, and watch rules. So they are quite similar, actually, and you can define the same things. Well, I talked about identity already. So you have your application, and an identity can be a person, but it can also be a service, a microservice. So for that, you have service accounts, microservice accounts, if you will. So you can prove that you are that service or user by entering your password, or that you are a certain service. So you can use user password credentials for that, or a connection string. You can use a service account credential file, which in GCP is a JSON format, and it contains a private key, which is sort of the same like a password, but it's easier for machines to use. And you have OAuth tokens, which are sort of a delegation, a way to have a temporary token, which you can use to prove that you are that application. So how do you obtain such proof? Of course, you can hard code it in the secrets or the environment variables or somewhere in the resource manager. But you can also, that's one, and you can also put it in an environment secret. So in Kubernetes, you have secrets. In Google Cloud, you have metadata, and in the same principles hold for other platforms. But you also have the network option. So you can retrieve your credentials from the metadata service of a cloud provider. This might be not known to a lot of you. So a metadata service is something that I'll come back to later. So you see that there are different ways to access the same or identify as the same server accounts, which can then access cloud services like a database. So now I will enable the questions. Please open that URL. And I have a question about how does your most recent project authenticate to the database, if it has a database. So suppose that it's a web app, then it probably has a backend which accesses a database. If it's a mobile app, it probably also uses some kind of backend which then uses, again, a database. And I want you to share how your project, you don't need to disclose the name of the project, but just how does it store these credentials and how does it provide them to the SDKs of the libraries that use the database.
I'm not seeing the question yet. So either I got the URL wrong or...
Oh, do I need to do something special? I did not put the, no, you please specify your answer as a question. Sorry, that was not clear.
Ah, okay.
I did not put it as a general question. That's not possible here using this Q&A section, but I can get you to enter text at least. Cool, cool. I have 2 answers already. Yeah, nice. Third one. It's also possible that you don't have a recent project for this, but then let's, okay, nice. Another one. So suppose that your database access is now leaked. You don't know how, but you know at least that your the database is somewhere out there. It's on Pastebin, or some people complain that they that they see logins in other systems with the same username and password, that kind of stuff. So now your hairs are standing up, but how do you rotate the credentials? Can you again provide them in the same question box? How do you think about rotating those credentials? In the meantime, I will talk about what kind of different answers I got. So I see that some people use username and passwords. Other people use the fact that it's running on the same project. So for example, in Google App Engine, you don't need to specify which credentials to use, because it will just use the default credentials of the project, which you can set up to access the data store, for example. And some people are using service account key files, and some people are using Firebase. So Firebase, you get an authentication token, and then you can have security roles in that database. Great. So I see that people would, for example, reset the password, or they would disconnect an authentication token from the Firebase dashboard. And some people just burn everything, which is nice. But thinking about how would you then continue to use your application? So because you have now reset the password, think about how much time would it take you to roll out that password to all your application servers, or to create an access token, authentication token, I mean, and put that in all your deployments, or in your mobile app, for example, if you need to roll it out to via the App Store, maybe even. That's quite a lot of work, right? So ideally, you have some kind of automatic provisioning, and you don't need to do that manually. So the next part is about that automatic provisioning using compute and Kubernetes, because you don't want to do it manually. In Google Compute, AWS Compute, and Azure, you have something that is called the metadata API service. It's a funny thing because it is available at a IP address which you might know is in the link local range. So it's not a thing that you can route traffic to. You cannot. You can create a DNS record for this, but it will never end up at a router or a public network because it's link local. And the hypervisor injects this server in your VM of all the platforms. All the platforms do this. So AWS, Azure, and GCP all do this. And they provide some region information, metadata, zone, instance type, which project it is, etc. Actually, very interesting data. It is already available to you there. But it also provides you with identity documents. It's a general term for such a service account, key file, or an OAuth token. So in GCP, you can see there's a compute metadata API, which provides you with identity file. In AWS, it's a token, and in Azure, it's also a token. I think that in GCP, it's also a token that you see there, but I don't know if at the top of my head. And look at the reference for details about how to use this these APIs. So how does that work? First, of course, you need to create a service account. So this picture, the 1, 2, 3, and 4 are how you set up an account using a managed identity of Azure. So you would create the identity, you enable managed identity, and you create the identity. So you give it rights. Then from 5 on, you see that the API, the application, does something. It creates, it requests a token from the metadata API endpoint, and which then in turn will get an access token from the Azure Active Directory. And then your application can actually call the database using that token, which is nice, because you don't need to inject any credentials in this application yourself. You can just say, this VM has access to this database. And the token is actually OAuth token, which means that it's temporary. So it will be valid for like 2 hours, and it will refresh automatically. But if you somehow exfiltrate that from your VM, an attacker exfiltrates that, then he cannot use it from his own computer for longer than 2 hours, and he also cannot get a new one, because you can only get it from the metadata API server, which is inside the project. So he needs to have continued access to the application, which is great, because often that's not the case. And the same holds for all the other platforms. So then with Kubernetes, what do you think that happens? If you do not specify anything special for this, which roles of, oh, by the way, I skipped over that. I saw someone mentioning Firebase, and I saw someone using Cloud Run and App Engine. Those actually also have some kind of same mechanism for a metadata API. Some of those have a proxy, and some of those have, so they front the database with something that injects permissions for them. But the principle is the same. In the end, it uses some credential setup for the VM. So Kubernetes runs on different VMs in your cloud project, meaning that multiple different applications, like the one shown at the first slide, one of the first slides, are running maybe on the same node. So if you do not specify anything, and you just run this BusyBox image, which permissions do you think it will have? I can provide an answer already. In GCP, the default OAuth scopes are logging write, monitoring metrics, and storage read, which actually already is a bit too much, because it can read all storage buckets. And also, your application might require data store access, so you might have added permissions to access the database to this default services account, which means that every application running on Kubernetes can access that metadata API and then consequently use those permissions. But we wanted to have them separated. We wanted to have fine-grained access. And also, GKE does not require that storage read permission that is so broad. So how do you do that? How do you restrict that that access? You can, of course, inject this the permissions with a service account, so you can hard code them in your applications using that service account credentials file, or you can use workload identity. So the first one was sharing the access of the host VM, which is the default mode. And you see from those emojis already that there is some preference there. Workload identity is new, however. It was not available before April 2019. So you could not use this in any of the platforms. And then Google added this phenomenon of workload identity. And afterwards, also AWS and Azure quickly released a similar feature. So in GCP, it's workload identity because a pod or a container is a workload, according to Google. In Azure, it's called a pod identity. A pod is a term specifically to Kubernetes. And in AWS, it's called IAM roles for service accounts, which is a really nice name for something that is not really very Googleable this way. Then in my team, we used to use service accounts for each microservice, which is logical because before April 2019, it wasn't possible to use anything else except default credentials, which is bad. So we would copy that key file. We would download that key file to our computers and upload it as part of a Kubernetes secret. So it's sort of hard-coded. And of course, it's easy enough to upload that. We created tooling for it to do so. But we have that secret temporarily, at least, on our computers. And if you're not very thorough and very you're not busy with security that much, you can even leave those the service accounts sitting on your computer, which means that if somehow your computer gets compromised, the service account key file is out there. And the service account key file, you must see it as a sort of a password. So it's actually quite bad if it's leaked. You can revoke it and you can create a new one, but noticing it that it's leaked is hard. So Google advised us and generally advises everyone via the Cloud Information Security Audit, I think that the acronym is, to use workload identity. What is workload identity? Well, it's a way to link two kinds of server accounts. So if you know a little bit about Kubernetes, you know that it has service accounts also. And in the cloud provider, you also have service accounts, but those are not the same thing. So if you're just talking about compute, you have these GSA M1-like service accounts, as you see in this image, which is a service account which has, for example, access to PubSub and is just managed in Google Cloud or in AWS or whatever. And if you have a service account in Kubernetes, that typically defines how you can access the Kubernetes server. So it defines if you can access a certain pod or if you can access a certain deployment information. However, they don't specify something that gives you access to PubSub, the Kubernetes ones. So workload identity is the magic sauce that links these two kinds of service accounts together. You can use your Kubernetes service account to retrieve the credentials or the OAuth token for the service account that you can impersonate. So that sounds quite magical. It actually is not that difficult to use it. So how would you use this on, for example, Kubernetes? First, you must use a certain process which is called application default credentials. I already mentioned that term, but I did not really state that correctly. So let me go back a little bit. So application default credentials is a thing from Google. It is actually not a way of managing credentials, or it is a way of managing credentials, but it's not a credential itself. It is a strategy. So first, Google, all the libraries of Google look for hard-coded settings in their SDK for the key file. That's a way to reference the JSON key. And then you have the environment variable that all the client libraries read, which is Google application credentials. So you don't need to hard code it, but you can set it later using environments. And you have the network. It's also all the libraries use the network to retrieve it from the metadata API. So that's already built by all the SDKs. So then continuing, you need to check whether you support application default credentials. So you should not hard code the credentials, because that way you cannot easily migrate between a service account and workload identity. Then you need to create a Kubernetes service account. That's very easy, but then you need to use it in your application. And you need to map this Kubernetes service account to the GSA Google service account using workload identity user role and a certain IAM policy, which grants that access. And you need to assign of course, you already needed to assign the roles to the Google service account for PubSub. So often 4 is already done. And in our case, let's show an image of how this looks to ensure that you use application default credentials. So here you see an example of my project. We have here a data store class from the Google Cloud SDK. And we previously had some kind of a retrieval of that key file name, but we removed that. So we just rely on the fact that you can set the Google application credentials environment variable, but we don't specify it any longer. And then if you support ADC, you can then reconfigure your application to have the Kubernetes service account, which is shown on the bottom. There you see that GCP service account is actually referenced in the annotations. And you see that in the top, you see that the deployment now references the service account, and it no longer specifies the Google application credentials file. So that is actually the first 2 steps. That's already it. Then, of course, you need to link them together, and we want to create automatic tooling for that, but we don't have it yet. These are the manual steps to do so. So you, maybe it looks daunting, but it's just a few commands that you can execute, and it's actually creating the service account already on line 13, and then on 14 is creating the binding or the binding to the roles actually. And on the line 24, you define the mapping between the 2 service accounts. So that's actually it for Kubernetes workload identity. Of course, if you have a lot of applications, you need to do that everywhere. So that it might be a lot of work to change over to that, but it's fairly doable. That is already it. So long, and thanks for the fish. Now you know something about IAM and RBAC, and you thought about how your own application authenticates. And you have some basic knowledge about service accounts and the metadata API. And you also know a bit about workload identity. If you have any questions, please, you can still ask them at the link above, or ask them in person. And the presentation is public at this link. And the next slides contain a lot of references. So it contains references for how to set up workload identity. When they were announced, those the technology, it contains a bit about how hackers can do lateral movements within your system. So if they have access to one thing, how would they get access to other applications? And something about how that metadata API actually works. So here you can take a look to see how your platform does this. That's it. I will now stop the recording and ask some questions, or I received some questions.